Hello, guys. We are going to learn private function. QuickSort, understanding the private function in QuickSort. So, so here you can see the private helper function work as a part of implementing the QuickSort algorithm. So, goal of pivot function: select the first element as the pivot and partition the list so that all number less than the pivot are moved to the left side. Okay, so the number is less than from pivot move to the left side, and number greater than from the pivot uh, are moved to the right side. Okay, so for example, we have one list 3 comma 5 comma 0 comma 6 comma 2 comma 1 and comma 4. So pivot is we initially took 3 as a pivot number, which is the first element, and final goal: place 3 in its correct position so that all elements left of it are less than 3. Okay, and all element right side of it are greater than 3. Okay, so element which is greater than 3 in right side and which is less than 3 are in left side. So first of all, initialize the variable pivot first element. Okay, so index 0 and value is 3. Okay, here you can see this is our pivot number, index number 0 and value is 3. I loop variable starting from index 1. Okay, so here after that we need to start a loop from here 5 to 4. So I have index start at index 0 same as pivot index. Okay, so from here and loop 2 through the list. For each array of I, compare with the pivot. If array of I is less than pivot, increase the swap index. Swap array of I and array of swap index. If array of I is greater than equals to pivot, do nothing. Pivot element will be pushed right by default. Okay, so example, we have initial list. This one. Now we need to compare 5 with 3. Okay, so 5 is greater than 3. Okay, so 5 is greater than 3, so we don't need to move. Okay, now we need to compare 0 with 3. So 0 is less than 3, we need to swap. Okay, so here we can see swap 5 and 0. Here 0 in the place of 5 and 5 in the place of 0. Okay, here 6 is greater than, now we are going to compare 6 and 3. So 6 is greater than 3, so we don't need to move. Now again we are going to compare 2 and 3. Okay, here you can see 2 and 3. So 2 is less than 3, so so I need to swap index 6 and 2. Here 2 at the place of 6 and 6 is at the place of 2. And I need to compare 1 and 3 here. So 1 is less than 3, so we need to compare 1 with 5. Increment swap index, so swap 5 and 1. Okay, and compare 4 is greater than 3, so we don't need to swap this. Swap the pivot with the swap index, so swap 3 with 1 pivot placed correctly. So final partition list, this one 1 0 2 3 6 5 4. Pivot of index of pivot equals to 3. Okay, so recursion follow. So left colon array 0 and pivot index, and okay, right for array pivot index plus 1 and end. Okay, so pivot element itself is excluded from recursively, which is already sorted. Return value: the pivot function return the index of the pivot final position, not the value. The index help divide the list for recursion quicksort call. Okay, so summary. Pivot function is a core part of the quicksort. Uh, if partition the array in place, keep space complexity low. Swapping logic ensure elements are organized around the pivot for recursion. Here you can see the pivot function only using Lomuto partition scheme. Okay, so here you can see this is the function array pivot index and end index. Swap index equals to pivot index. Start with the pivot position. Here we can see transfers the subarray from the pivot index +1 to end index. Okay, and this is the final place. Finally, place pivot in correct sorted position here and return the swap index. Here you can see array of pivot index, comma array of swap. So both are we are going to swap these index again. Pivot index with swap index and swap index with pivot index. Here you can see if array is less than array of pivot index, we need to swap index increase by 1 and swap index. Now we are going to swap here again array of swap index and array of I. Swap index with array of I and array of I with swap index.